on every commit, but you test the most important tests, the features, the basic requirements, the smoke tests, and so on. So that you have an answer after 30 minutes. You get an email if it fails. If not, everything is okay. And the longer running tests, stress tests, and so on, robustness tests, you might run overnight or every 2 hours or over the weekends or something like that. It's very important to have fast results. Fail fast. That's the motto here. Now, let's have a look at the software architecture of the test system. So now we are talking about the test system. So just to show you that, I have this test system here on my desktop. That's the system under test. That's the wiring, and that's the test system. So now let's have a look at the test system. In the test system, you need to configure the wiring, so the hardware wiring, to switch it from, for example, from one mini-hill board to another, or just switch the wiring from PWM to ADC. That's where we usually use a little software component that switches the wiring to the next variant. So we configure the variant. First, we switch the wiring. Now we have the right wires attached. Now we switch the different component to the component we use. That's a structural variability. So we do not build the same temperature sensor in the same component, or different temperature sensors in the same component, but we actually have separate temperature sensor simulations for different interfaces. For example, that's an analog output that stimulates the sensor, and that's an SPI simulation that simulates the sensor, temperature sensor. Then we might have UART or LIN or CAN, different bus systems, different bus protocols, many applications out there that can use a LIN or a UART or a PWM or a CAN to actually, for example, set the motor speed for a motor controller for a pump or something like that.